let's now take a quick detour and talk about what's known as the factorial function. Let's look at the definition. Suppose we have an integer k. Okay, so k is 0, 1, 2, 3, 4, 5, and so on and so forth. So we define the k, we have the following definition. Now we read this as k factorial, right? Not k. You don't have to yell when you use this function, right? So k factorial is equal to k times k minus 1 times k minus 2 times all the way to 3, 2, and 1. And then we have a special case where we have 0 factorial is by definition equal to 1. Okay, so let's look at a few examples. Suppose we have 3 factorial. 3 factorial is equal to 3 times 2 times 1, which is going to be 6. 5 factorial is going to be equal to 5 times 4 times 3 times 2 times 1, which I believe is 120. And then 8 factorial, for example, is going to be equal to 8 times 7 times 6, 5, 4, 3, 2, and 1. And that gives 40,320. And then, of course, 0 factorial is going to be equal to 1. So nothing too fancy about this, right? Now, you do want to be careful about using the factorial notation. Here's an example. Does anybody know how many strawberries are there in a naked juice bottle? Apparently, they told us, which is 22 factorial. Okay, fine. Now that begs the question, how did they find this number of strawberries? Because I know that this is million. Okay, and this is billion. This is trillion. Okay, so how did they even find this gazillion strawberries? Now this is obviously a joke, right? We all know that they meant 22. But now that you know the notation and you know the factorial function, you should be really careful about when you use the exclamation mark. Okay. So in this video, we looked at the factorial function. All we need to know is the definition because we're gonna need to use it for our calculation. So let's then move on to talk about the how to find probability for a binomial random variable.